of dam, we may require a large area for which the surroundings may be submerged, isn't it? This is about a hydropower plant. Now, let us see about the next one, that is nuclear power. Let us talk about the next option in conventional sources, that is the nuclear power. We know that by nuclear fission and fusion actions, a lot of heat is generated. This heat that is generated can be used for generation of electrical energy. The heat is converted to steam, the steam is forced onto the turbines generate mechanical energy is given to the alternator which converts electrical energy. Likewise, we have, if we take the case of a nuclear power station, it looks like this. Now, let us see about the nuclear power. Let us consider a heavy atom. When a heavy atom is hit with a neutron, it splits into two smaller atoms, as well as it releases the neutrons, which once again collide with other atoms, and once again the process continues. We know this process is called as a chain reaction. In this case, the heavy atom which is getting split into two smaller atoms, the weights of the two smaller atoms is not equal to the heavy atom. The mass deficient that we are obtaining is converted as heat. That heat is given to the water, which gets converted to steam. The steam is given to the turbines, and thereby we can have electrical energy. That is, let us see, when an electron hits, it splits into two and heat is generated. This heat is given for the turbines, isn't it? This is how we go for the generation of nuclear power. The advantages being, the nuclear material that we are using, it is a very highly concentrated form of energy, isn't it? It is a very highly concentrated form of energy. And if we see, if we fuse 1 kilogram of nuclear material, the energy that is generated is equivalent to burning of 4500 kgs of high grade coal, isn't it? See, this much energy that we are able to obtain. And the transportation of nuclear fuel is not a problem if proper radio containers are taken care of. The only disadvantages that we have for nuclear power is that radioactivity is a problem. Limiting the radioactivity is a problem. Next one is the disposal of radioactive materials is a problem, right? These are some of the problems that we need to take care of, as well as the heat extraction. The heat that is generated by the nuclear fusions is very difficult. Okay. Now, let us talk about how the nuclear power plant works. That is, nuclear fusion makes heat water to make steam, steam runs turbine, turbine runs generator, electrical power sent around the country. Let us see a photograph of a nuclear power plant which is situated in France. This is about the nuclear energy that we have talked about. Now, let us talk in detail about the fuels. In fuels, we have solids, liquids and gaseous. Fuels can be classified into three: solids, liquids and gaseous. Now, let us talk in detail about the solid fuels. Fuels. In solids, we have two types of solid fuels, that is wood and coal. Wood has got very low calorific value, so it is not generally used for generation. Coming to coal, we know that coal is formed because of the vegetation that got buried under the earth's crust. Because of the pressures and temperatures, it got converted into coal. The very first stage of coal is known as peat, which has got very low calorific value. The next stage being lignite, which has got some better calorific value than that of peat. We have got some more types of coals. Let us see them. They are subbituminous coal, bituminous coal, super bituminous coal, semi anthracite coal and anthracite coal. Of these, bituminous coal is mostly used for generation of steam. Okay. Now, let us talk about the next type of fuel, that is liquid fuels. Liquid fuels, we have got the various types of fuels being gasoline, kerosene, gas oil, diesel, petrol. These are some of the gaseous liquid fuels that we have. Now, let us see some of the advantages of these things, that is, there is no handling problem, less space is needed, less number of auxiliaries and neat and clean. These are the advantages that we get compared to that of the solid fuels. As in solid fuels, the system is not clean, pollution is very much there, whereas here the system is clean and handling of fuel is not a problem. Now, let us look into the next one, that is the gaseous fuels. In gaseous fuels, we have natural gas, producer gas and byproduct gas. The natural gas is obtained from gas wells, whereas producer gas, it is a manufactured gas, and the byproduct gas is from coke oven or blast furnace. The same advantages what we have for liquid fuels, the same advantages we can state it for the gaseous fuels. The system is clean, number of auxiliaries are less space is required, isn't it? Now, let us look, please answer this simple question. In which of the following power stations the electrical energy is produced utilizing the heat energy in coal? Is it hydel, solar, thermal or nuclear? Which one is the right answer? Yes, the answer is C, because in thermal power plant, coal is the main fuel that is used for generation. Let us please answer one more question. In nuclear stations, the fuel used is it gas, coal, water or is it thorium? Yes, the fuel used is thorium, because we know that plutonium, thorium and uranium are some of the nuclear fuels that are used for generation, isn't it? Now, as we had talked about the conventional sources, now let us look into the details for non-conventional sources of energies. They are solar power, wind power, tidal power, wave power, MHD means magneto-hydrodynamics. We have got geothermal energy, thermoelectricity, piezoelectricity and biomass or biogas, and we have